evening and welcome to the launch of the Team Bath Racing's latest race car, Team Bath Racing 21. I'm Benjamin Jenkins, the project manager of the team. Thank you for joining us this evening. We're really delighted that, in spite of current circumstances, we can still celebrate the achievements of the 25 engineers who form TBR 21. Before we reveal the car to you, we're going to cover a few things. Firstly, what is Formula Student? What is this competition and why has it been so important to all of us for so long? Who are Team Bath Racing? What is our history and what do we do? Then we will launch our brand new car, TBR 21, and talk you through some of the key features of its design. We will then recognise all of those who have inputted to this project and made it possible over the past 16 months. I will introduce to you the TBR 21 team, discuss our plans for the coming months, and finally, we'll run a short Q&A session, giving you the chance to find out more about the TBR 21 car. You can submit your questions using the Q&A box available on the live stream. So first, what is Formula Student? Well, in a line is an international design and business challenge for university students. Every year, we design, build and race a brand new single-seat race car, like the one you can see here. That is TBR 19, the last car we raced at competition. But that doesn't give you the full picture, so let me put a few numbers on it for you. There are 823 teams competing worldwide, both combustion and electric powered. These teams compete at 15 competitions across 5 continents. Each competition is worth 1,000 points and is split into 2 classes, Concept Class and Formula Student Class. But what are these classes? Well, I'll start with Concept Class. This is where every Team Bath Racing team begins. We in TBR 21 competed in a version of this competition last year, and next year's team, TBR 22, will be competing in this class this year. The Concept Class competition is for paper designs only, so teams that have not yet built their car. At TBR, we use this competition to gain feedback on our design prior to building the car the following year. The competition comprises of 3 static events. The dynamic design event, worth 150 points. Here, we are questioned on all of our design decisions, the process we followed, and are forced to justify how we reached our final design. The cost event, worth 100 points. We cost the whole car and justify why we used the various materials and techniques. And finally, the business event, worth 75 points. We produce a full business model to sell the car in real life. Because after all, what's the point of designing something that you then can't sell? Moving on to Formula Student Class. This is the area of the competition that we will be competing in this year. Here, we retain the 3 static events from Concept Class and add 5 dynamic events. Firstly, the acceleration run, worth 75 points. A 75-metre, straight-out, all-out acceleration run, designed to test the car's maximum acceleration performance. The skid pad, a figure-of-8 track designed to test the car's lateral acceleration. The sprint event, a 1-kilometre all-out lap of the track, most akin to a Formula 1 qualifying event. Here, the car and driver are going at maximum commitment, seeking to produce the fastest lap time. And the endurance event, a 22-kilometre grueling endurance run designed to test the reliability of the car. Many teams fail to finish this event, which is why it carries such a high points weighting. And finally, the efficiency test. Here, teams are scored on the amount of fuel or electricity they use during the endurance run. Obviously, the less used, the better. So what is Formula Student? I've given you an idea, but now we'll see a short video to tell you a bit more about the competition. So that is Formula Student. But what about us at Team Bath Racing? Where do we fit into this? Well, we are the University of Bath's combustion-powered Formula Student team, comprising 20-odd mechanical and electrical engineering master's students. We are one of the UK's oldest Formula Student teams, founded back in 2000, under the name of Bath University Racing Team. We competed with our first paper design in that year, and since then, every year, we design and build a brand new Formula Student car, starting from a clean slate. We produced our first car in 2001, shown here. Since then, we have continued to develop every year. In 2006, with this car, we rebranded to the name that we all know today, Team Bath Racing. Throughout our history, we have had great highs and crushing lows. On the left, our first endurance win at FS UK 2015. In the middle, Formula Student Czech in 2016, where we became the first UK team to win a Formula Student competition outright. And finally on the right, the TBR21 concept class design that was crowned overall champions at Formula Student UK's virtual statics event competition last summer. So that tells you who TBR is. Now, let's have a brief look at some of our recent history. Starting with TBR17. This was a car that was produced when the current team was all first years. This was the first TBR car to use a full carbon fibre monocoque chassis, so it was a huge technological achievement for us. It maintained the KTM 500cc engine that was brought TBR16 so much success in the previous season, and also continued to develop on the full aerodynamics package concept introduced with TBR15. Although this car performed very well, including qualifying for the highly prestigious Formula Student Germany design final, notoriously the hardest design final to qualify for, it was not able to repeat the success of its predecessor TBR16, but it was still a very successful car nonetheless. Next is TBR18. This car introduced the larger KTM 690cc engine, along with a solid spool rear axle. It continued to develop the full aerodynamics package, producing one of the more visually appealing cars TBR has ever built. This team cleaned up at the concept class competition at Formula Student UK in 2017 and was able to carry that success into Formula Student class in 2018, with an excellent third place overall and second in endurance at Formula Student Austria. Then came TBR19. This was the most technologically advanced car TBR had built to date, with features like front and rear wing drag reduction systems. This led to another strong performance at Formula Student UK's concept class, with a third overall and second in the design event. However, it was not able to carry this performance into the 2019 Formula Student season, but we have learned an awful lot from this car. Finally, our predecessors, TBR20. This car continued the tradition of concept class success, winning the design event at FS UK. We did have great hopes for this car in Formula Student class. However, the events of last year and COVID-19 forced the project to end early before the car could be built. This was a great shame for everyone who was involved in the project, and we, particularly in TBR21, are grateful for the support that TBR20 have since given us. So, I've spoken about the team's recent history, but what about us as TBR21? Where have we come from and how do we fit into all of this? Well, it all started for us last year in February when we all met for the first time in a room in the Department of Mechanical Engineering here at the University of Bath, part of the Group Design and Business Project stage of our third year curriculum. It was there that we set about the challenge of designing our own brand new Formula Student car from scratch. It's at this stage that we're encouraged to come up with any ideas that could be incorporated into a Formula Student car's design, and also to investigate previous teams. Early on in this stage, we determined our design philosophy, and this has guided our efforts for the past 16 months. Our design philosophy is as follows: to design a lightweight and reliable car whilst maximising the handling performance. And we believe that a car that embodies this philosophy is capable of winning a Formula Student competition. So we took that philosophy and began distilling down our ideas into a workable design. However, partway through the design process, COVID-19 struck and the team had to split. Many of us returned to our homes, which for some was overseas as far away as China and Malaysia. However, we did not stop. Like many people, we were forced to adjust to the new realities and continue working in preparation for the 2 virtual competitions we had lined up in the summer. And this was the design we produced. As I said, we then took this design to 2 virtual competitions, the first of which was Formula Student UK's virtual statics event competition. Here we competed in the 3 static events against 80 other teams from around the world, both Formula Student and concept class teams. We performed very well, reaching the design and cost finals, and then this happened. We were crowned the overall winners of the competition. This was an incredible achievement, as not only had we won a Formula Student competition, but it was Formula Student UK, our home event. And we were a concept class team, competing directly against established Formula Student class teams. Alongside winning overall, we secured 2nd place in the design event and 4th place in the cost event. So an excellent competition for us. Boosted by this success, we went on to the 2nd virtual competition in August, Formula Student Online. Here we continue the success, this time winning the business event and finishing 5th overall. So really, it wasn't a bad start to our Formula Student journey. But we didn't sit back and admire that success. We took the feedback we got from both of those competitions and set about modifying our design, ready to build the car this year. After a slight delay to normal years, we got back into our build room in October and were able to begin the design building process, whilst also managing all the restrictions imposed by COVID-19. Just recently, we all completed our last piece of university work, our final year projects. However, unlike many of our contemporaries who have now decided to take some time off, we didn't have that luxury. There was no time for us to relax. We were back in the build room, working harder than ever, getting ready for today. The fact that we have made it to this position today is a huge testament to how everyone involved in the TBR21 team this year has managed the challenges and restrictions that have been imposed on us. It has not been easy at times, but we have carried on regardless. And now, that brings us to the moment we've all been waiting for. The moment we can finally reveal to you what we've been working on so hard for so long. Therefore, it's my great pleasure to introduce to you our brand new car, TBR21. So here she is, our brand new Formula Student car. We cannot be more proud of what we've been able to achieve this year. As I said, it's a huge testament to everyone who has been involved in this project, that we are here today with the car looking as it does. Let me now run you through a few highlights of our design. We've continued with the carbon fibre monocoque of previous years for its lightweight and high torsional stiffness. The KTM 500cc engine makes its return to TBR, turbocharged as before and running on E85 fuel. A pneumatic gear shifting system replaces the hydraulic system of previous years, targeting improved reliability and performance. A full car aerodynamics package is included with front and rear wing adjustability and brand new innovative side venturi tunnels. Car's wet mass of 170 kilograms, an excellent achievement and meeting our lightweight design philosophy. Combine that with 72 brake horsepower, 66 Newton meters of torque, and the ability to pull 2.2 G of lateral acceleration through a fast corner, makes what we believe to be a highly competitive Formula Student car. Let's now hear a bit more from the technical leads, telling you what's been going on and the work that their department has done this year.
TBR21 is using a full carbon fibre monocoque chassis for its low mass and high torsional stiffness. The layup has been optimised from previous years through the use of high stiffness and high strength carbon fibre plies. The high stiffness plies have only been used in areas where local stiffness reinforcement is required. This keeps the mass low and has provided a 3 kg saving over the previous TBR monocoque. This has also meant that our torsional stiffness is 4,000 Nm per degree, a 10% increase. Other areas of optimisation and innovation include carbon fibre tubed jacking bar and a minimum length impact attenuator. We have also used an adjustable pedal box for accommodating different driver heights.
Some of the key objectives of the powertrain team this year was naturally to create as much power as possible, but also to be lightweight and reliable. This meant that we shifted away from the KTM 690 back to the KTM 500. This yielded over 10 kilograms of weight saving. We will turbocharge the engine in order to maximise its power, and we're running E85 fuel. This enables us to no longer need a charge cooler, again saving a couple of kilos. In the further pursuit of weight saving, we've created an additively manufactured Inconel exhaust outlet flange from the turbo. This is not only lighter than a machined counterpart, it's also able to withstand higher temperatures and improves heat transfer. We then have a titanium exhaust, again saving more weight over the steel exhausts of the past.
The Vehicle Dynamics department have worked tirelessly to bring improvements to all areas of the package. Significant emphasis was placed on targeting unsprung and rotational mass reduction, as well as minimising compliance throughout the suspension system using learning from previous teams. The most notable ways that we have done this are by developing additively manufactured uprights, carbon fibre wishbones with sintered brackets, and aluminium rear hubs which feature a steel EDM insert for the drive shafts. A tunable rear anti-roll bar is coupled with adjustable ride height, camber and tow both front and rear, and this should allow the car and the driver both to be optimised and to improve the performance of both of these aspects.
The TBR21 aerodynamics package has been optimised for both strength and aerodynamic downforce generation. We've achieved this primarily by using a rower cell core in the wings and in the end plates, which gives us the stiffest and most rigid package that we've produced to date. In terms of design, we've optimised the side aerodynamics, as this was the area where we had the most to improve. We've done this through designing some aerodynamic venturi tunnels which also house the radiators. This allows us to generate downforce whilst also sufficiently cooling the car, a feature that was not present when we were using side pods. We've also then been able to generate downforce through side wings, which have replaced our kicker plates, so we don't have as much drag on the rear tyres whilst improving our overall downforce generation.
All of this has been an amazing achievement, but it would not be possible without the support and dedication of all of our sponsors. I would love to mention them all individually, but there are simply too many. However, we could not do what we do without your support, whether it's financial or in kind with materials, components or software. It allows us to take our thoughts and the theory, apply them to the real world and turn our designs into a reality. There are more people to thank as well, because so many get involved in this project. Firstly, Drs. Kevin Robinson and Dr. Speed Owen, our two academic supervisors. These two have been involved with TBR for so many years now, and their experience and guidance is invaluable to ensuring TBR reach this position every year. The University of Bath technicians, these guys put in so much work to support us with making components, helping through redesigns, or providing knowledge on things like composites manufacture. Professor Gary Locke, the head of mechanical engineering here at Bath, has been incredibly supportive this year and helping us manage the various COVID restrictions to ensure we could still build a car. Similarly, Dave Wood, who's helped us manage the restrictions, as well as numerous other tasks that have kept TBR21 functioning this year. The university's academic staff, who help us and support us with design work and through their technical expertise. The university finance team, they handle all of our purchasing requests and liaise with suppliers to ensure deliveries arrive. Add to that the mechanical engineering department office, who then handle all of those deliveries when they arrive and get them to us. Kai Pearce-Rees, our invaluable IT support. He's helped us with numerous little issues this year, as well as providing his own insights from his own involvement with TBR over the years. Gareth Lewis from Whitewater Studios, who again has produced all of the logos for our awesome livery this year. Lars Jones, he's very kindly welded our brand new titanium exhaust for us. A few more people, all of the TBR20 team, who, as I said earlier, despite their own project ending prematurely, have supported us throughout. Chris Bull, one of our alumni from TBR19, who has provided invaluable assistance and support with the electronics and wiring loom design. Nick Evans and Bill Phelan, two PhD students here at Bath, who have been assisting with our engine dyno work. Several members of TBR22, next year's team, who have helped us out with numerous small design tasks since the start of the year. And then finally, Oscar Morgan, who designed the TBR21 logo you can see on the car headrest, and also Paul Bianchi, who designed the launch event advertising poster that many of you will have seen across our social media. So, you've seen the car, but what about the team that's made this all possible? Well, I'll start with the chassis team, led by Tom, who you met earlier. Tom has been responsible for our chassis shape this year and designing all of our monocoque inserts. These are the little devices that we need to bond anything to the chassis. Matt Rawlins, who's handled all of our SES this year, making sure the chassis is structurally strong enough, as well as costing the chassis. And Gwyn Vo, who's designed all of our safety structures. So this is the front and main roll hoop, as well as the impact attenuator. And then Samir Patel, who's designed our driver environment, as well as being our business manager this year. Moving on to the powertrain team, led by Ben. Ben has been responsible for our engine dyno running, which is calibrating our engine, as well as doing our fuel system. Roman Demidenko has been looking into our cooling system this year and designing our new radiators to fit inside the side Venturi tunnels. Charlie O'Connor has looked into our lubrication system, as well as assisting Ben with all the dyno running. Alex Rybnishki, our intake system designer, responsible for selecting our turbocharger this year and also doing most of our powertrain simulations. Derek Tew, who's done our driveline. Sam Cornwell, our resident spanner monkey. He's been around TBR for several years now and has joined this year and picked up numerous tasks, including our pneumatic shifting, clutch operation, and also the exhaust system. We're very grateful that he's come on board this year, as he has a wealth of knowledge and practical experience that have been invaluable. And finally, myself, working on the electronics. Now on to the vehicle dynamics department. This is our largest department, led by Sam, who's been responsible for all our suspension geometry, as well as having a hand in most other aspects of his department's work. Johnny Damant has done our steering system and has also been looking into our simulation models of the full car. Shay Grant, part of our outboard suspension design team, who's done our wheel hubs, including our new aluminium rear hubs with the steel EDM insert. James Parks, who has designed all of our inboard suspension, which includes our rockers, the mounts, and the rear anti-roll bar. He's also been in charge of our social media this year. Nick Pilato, he's selected our wheels and tyres this year, but more importantly, he's done an excellent job as our build manager, getting all our parts manufactured and delivered on time. Connor Smith, amongst other things, has designed our amazing additively manufactured uprights. and he's also been our sponsorship coordinator this year, had a large hand in build, and has designed the awesome livery that you see on the car today. Ryan Yu has done our brake system, and finally Daniel Almond, the last of our outboard suspension designers, responsible for numerous components, but more importantly, he's been our finance man this year, sorting out all of our orders and keeping track of the budget. Now on to our final department, aerodynamics, led by Jason. Jason has been in charge of all of our full car computational fluid dynamics work this year. A huge job, responsible for getting all the different parts of the package working together. This is especially challenging given those new Venturi tunnels. Dan Galpin has designed our front wing, and he's also our testing manager, so he's busy planning our activities for the coming weeks. Matt Ing, our undertray designer, who is responsible for those side Venturi tunnels and also the diffuser. He's also been leading our business plan group. Jack Hines, another person who joined the team this year, he has worked with Dan and Matt, optimizing the intakes of the Venturi tunnels to work with the front wing and maximize the effectiveness of both these devices. Abhijit Kahana, who's designed our rear wing, and finally Hannah Slater, who's designed our side aerodynamics, as well as organizing all of our team kit for this year. So you've met the team, you've met the car, but what's next for us? Well, quite simply, we're going testing. We now have the car, but we need to make sure that everything is working and performing as we designed, ready for competitions this summer. Speaking of which, where are we going to competition? Well, sadly, due to the travel restrictions and logistic issues with overseas travel, TBR cannot go on tour this summer. This is a great shame for all of us, as we would have loved to have pit this car against top European teams at various competitions throughout Europe, but it's just not possible. However, we do have a title to defend. So we're heading to Silverstone at the end of July for Formula Student UK, with the intention of translating our victory from last year into victory again this year. That is all from me. Thank you very much for attending. It's been great to showcase what we've been able to achieve this year, and I hope you've enjoyed it. We will now run a short Q&A session with myself and the technical leads up here on the stage. Please give us a moment to set up, and in the meantime, please enter any questions you may have in the Q&A section on the live stream, and they will get relayed to us. Thank you very much. Off stage, we have Connor Smith, who's going to be presenting your questions to us. So when you're ready, Connor.
Thank you. First question to Ben. Ben, have any TBR students made it into F1 in the past?
Yes, they have. We have a huge number of TBR alumni who've gone into the Formula One teams. In fact, I believe we pretty much have at least one alumni in almost every Formula One team now. Formula One views Formula Student as a huge benefit in terms of experience coming through into Formula One. So it's definitely a key stepping stone if you're interested in that form of career.
Thank you. Next question to Tom. Tom, the 170 kilo mass of the car is very impressive. Where do you think the biggest mass saving has come from?
Well, the monocoque has definitely provided a massive saving there. The 3 kilograms is huge for us on monocoque design. If you compare that to a space frame, the space frame would perhaps be over 30 kilos just in chassis. So it's a huge saving there that we've definitely capitalised on there.
Sam, some of the audience have noticed the wishbones of the car are metal at the minute. Are these changing to carbon in the future?
So we have a couple of plans. Yeah, the stuff you can see on the cart at the moment is all aluminium. But we're also having, along with progressive technology, some carbon fibre wishbones designed and made. Those are going to be fitted to the car for competition, along with the additively manufactured uprights and the sintered sort of aluminium and titanium brackets that they bond into at the end. So another decent save. I think we're about half the mass of the wishbones when we add those onto the car. But yeah, just still sort of going on the car a little bit later.
Next question to Ben. Ben, when can freshers get involved with TBR?
So freshers can get involved straight away. Every year we run an introductory event at the very start of the academic year. This is normally in October. We will publicise details of this on our social media accounts. But yeah, if you're a first year or if you're joining Bath in October, what I suggest you do is make sure you follow all of TBR social media accounts, but also sign up to our dedicated group, TBR21 Student Volunteers. We use this group to publish all activities going on and opportunities for you to get involved. But we definitely benefit hugely from the involvement of first years. Sadly, this year's been slightly different with all the restrictions, but in normal years, we very much welcome first years coming down and getting involved. It's a great way to learn yourself, learn new skills. So I definitely encourage anyone who's joining as a first year to get involved. But not even first years, I'd say anyone who's involved, even if you're not doing an engineering degree, you still have skills and expertise that may be of relevance to the team. So don't be afraid to get in contact and find out how you can get involved. Come down to our build room in 4 East here at the university and get talking to the team, get to know us, and we'll find jobs that can suit you.
Ben Gasson, are we thinking about using synthetic fuels in the future? Is there any interest in that moving forwards?
Yes, so I think looking forwards, at the moment, so we use E85 fuel, which is a blend of 85% ethanol and 15% gasoline, which gives us sort of numerous performance benefits. But synthetic fuels, I think, definitely play a massive role in the transport sector in general, but definitely in sort of high performance areas such as motorsport. What it'll enable us to do is use these same fuels, which we know and love, in engines, because ultimately that's why we all join this team, is because, you know, the joy of the engine and the excitement of it. So being able to use a carbon neutral synthetic fuel in the future, I definitely believe does play a role in the future for motorsport, definitely.
Tom, what actually is a carbon fibre monocoque and how do we make it?
The carbon fibre monocoque is essentially a sandwich panel of strands of carbon, which are woven into a cloth type sort of sub consistency, and then it's infused with the resin. You play that onto a surface. We use a carbon fibre mould, and then you can cure that in an oven, and that will become a rigid component effectively. You then add a core to that, and then a second skin of carbon fibre, and that creates a very strong, stiff chassis effectively, which is like a bathtub but in carbon fibre effectively.
Jason, how do we actually design the wings on the car? Do we use a wind tunnel or?
Yeah, so for us, the most valuable tool that we have in Team Bath Racing is computational fluid dynamics. We do all our main development work in the CFD environment, and then we correlate that back to the real world using known experiments, so that we are observing the correct flow patterns. As Ben mentioned, we'll be going testing in the near future, so we hope to get some on-track testing on our car, make sure that what we were seeing in the virtual environment is indeed what we're seeing in real life. Typically, Team Bath Racing does use a wind tunnel at the University of the West of England. However, with the COVID restrictions, we don't think we'll be getting that luxury this year. So on track and CFD it is for us.
Question to Ben Jenkins. Ben, what percentage of the car is carryover from TBR 19? How much of the car have we reused?
There is very little carryover from TBR 19. We've retained the same shape of chassis, but apart from that, pretty much all of the car is reasonably new. We've changed the magnesium OZ wheels, but yeah, most other stuff is new. And although we've retained the chassis shape, the actual layup of the chassis, as Tom described, is a brand new layup.
Ben Gasson, we've got some questions about the video. Do we have our own in-house engine testing facilities?
Yeah, absolutely. Engine testing for us is a really fundamental and important part of the process in creating a good high performance vehicle. So we have a engine dynamometer in our build area in our workshop. So this is a sort of small laboratory essentially, which allows us to run the engines in a controlled environment against a machine which applies load to the engine. What this does is it enables us to carry out all of our engine mapping and calibration work, so we can set our fueling, temperature control, make sure we're generating as much power as possible, ensure the turbocharger is working as efficiently as possible. But also it lets us carry out other control tests, such as testing the cooling circuit, testing the lubrication effectively, and it enables us to, say, run consistent engine experiments and testing, which wouldn't necessarily be as easy to achieve in the car on track.
Sam, we've obviously saved a lot of weight from the suspension package this year. How do we go about making sure it's still reliable?
So the main thing we've introduced this year is a part classification system. So every part on the car is either a safety, reliability, or other class part. For any safety parts, we essentially have a different safety factor for each of those parts. And we also sort of predetermined which of those are classed as fatigue parts. For those, we use an infinite fatigue life stress limit, and for the other ones, we obviously have the safety factor on the yield of the part. And essentially, that's how we go about it. We take the weight out, but we absolutely have to make sure that we hit the load cases that we have, that we work out through our wishbone loads, which are derived from the wheel loads. Essentially, through using that, we know exactly what we're, at a worst case, expecting to see on the car, which we can check against some of the old data that we have. And then we can essentially use that with the safety factors that we predetermined to be confident that the parts are still going to withstand the loads that we're expecting to see on track, despite the weight that we've taken out of them.
Jason, you mentioned something called Venturi tunnels. What actually are those on the car, and how do they work?
So the Venturi tunnels are the very big parts that you can see on the side of the car, between the side wing and the monocoque. Essentially, you get air that flows in through the inlet. It then gets compressed slightly so that it speeds up before then slowing back down as it approaches the radiator. This creates a low pressure zone underneath the tunnel with a relatively higher pressure over the top, and therefore we can create downforce from that.
Ben, we've heard a question about the skills the team needs to design and build a car like this. Do you think we've developed these skills at university, or is it from previous experience in racing?
I think it's a mix of both, to be honest. We obviously get taught an awful lot during our first few years up until we joined TBR here at university. But many students, particularly at Bath, do a year in industry. And from that, we learn numerous skills related directly to industry. So the team this year, we're very fortunate to have several members who spent time at Formula One teams, including Mercedes and Williams. Ben himself spent time at a marine company doing engine calibration, which is why he's been running our dynamometer this year. And that's a skill that he wouldn't have picked up here at university. So it is a balance. We learn from both. I think that's the key, isn't it? You're always learning new things, and TBR is just a place where you can actually apply those skills you've learned throughout your time.
Okay, a question to all of you, one at a time. What's your favourite part on the car?
Well, I'm going to go with the carbon fibre tube jacking bar, just because it was one of the things that I did myself. Quite pleased with how much mass I've saved on that, but yeah, it's not very exciting, but you need it.
My favourite part's probably the additively manufactured uprights. They're not fitted to the car at the moment, but they're going to be running competition. Connor's put a massive amount of work in, along with Progressive Technology, who we're hugely grateful for, to design those and 3D print them out of, or sinter them essentially, post machine them, and there's so much work gone into those. They save a massive amount of weight over the previous stuff that we've used, and yeah, they look pretty awesome as well.
I would say for me, naturally it's got to be something in the powertrain, something to do with engines. All the other stuff is kind of irrelevant until you can actually move the car, in my opinion. That's obviously, you know, a bit of a joke. These guys are actually quite important. But yeah, I'd probably say the turbo is pretty cool. The engine at the moment, you know, without a turbo probably makes like 45 horsepower. We add the turbo on, which does inherently have a whole load of different challenges, and we'll get up to over 70 horsepower, which puts us quite at a sort of quite a competitive level for Formula Student. But you know, beyond that, we've got a number of really sort of advanced and intricate pieces of design work that we've actually carried out ourselves in the powertrain. In the powertrain, so we've got its titanium exhaust, which is incredibly lightweight. We're currently working on some hard anodized wheel hubs for the drive line. So those again save us around like 1.5 kilos over the steel versions. But I mean, overall, I'd say, you know, the level of innovation and work that goes into the car as a whole does make it pretty hard to pick out individual pieces, and definitely, you know, the team effort to create this thing is really impressive.
Yeah, just echoing Ben, the team effort to have gone into this car is incredible. For me, it's got to be the cooling Venturi tunnels. These provide well, what we're seeing is approximately 100 Newton downforce shift from the side pods to these Venturi tunnels at our average competition speed of 55 kilometers an hour. So for me, they just make so much sense and are, well, new and, as far as I know, unique within Formula Student, which I think is testament to how hard the aerodynamics team has worked this year on this car and this package.
Well, thanks guys for probably nicking all the things I would have said anyway. So I'm gonna have to go with one thing to win me potentially a few brownie points with Connor, and say this livery we've got on the car this year, slightly different approach to past TBR liveries, but I think you can agree he's done an awesome job of both doing a bit of design on it, but also he's been responsible for actually applying it to the car, and I think it looks absolutely stunning. I'm really looking forward to see how it looks when the car's moving at some speed.
Well, on that note, I think we'll call an end to the Q&A session, end on a high. Ben, I'll hand over to you to close up.
Thanks, Connor. Thank you everyone for taking the time this evening to watch. I hope you've enjoyed it. I hope you found it informative. We're really glad that we've been able to reach this position this year. It has been a lot of hard work, a lot of struggles, but as you can see, the car looks great. It's a huge relief that we are at this stage. Just before we end, there's one group of people who still deserve a massive thank you, and that is the backstage crew here at uni. You can't see them all because they're hiding behind the cameras, but they've produced this event this year, including all the lighting, the sound, the pyrotechnics you saw earlier, and the camera work. It's been a great to have them on board this year. It means we've been able to produce this event to such a high quality for you sat at home. Ideally, we'd have loved to have done this with you here in person, but COVID restrictions obviously have put an end to that idea very quickly. But we hope that the work that they've done with us has been able to bring you a suitable launch event. So yeah, thank you very much to the backstage crew.